I guess the most important part of year 11 trig were all the formulas. The formulas were, I don't know, what cosec theta was, what sec theta was, cot theta was. Cosec was 1 on sine, sec was 1 on cos, cot was 1 on tan, tan was sine on cos, cot therefore becomes cos on sine. Do we have anything else? We have obviously sine squared plus cos squared also equals to 1, and then from that we get sine squared equals to 1 minus cos squared by subtracting, or you get cos squared equals 1 minus sine squared. That was generally required for the proving questions and sometimes for solving. Any questions about that? Then I guess after that, then you would have learned solving. And the most important bit of solving trig for year 11 would have been your all stations to central, where all of them are positive. Sine is only positive. Tan is only positive, and obviously cos is only positive here, right? So I think we pretty much should remember that. More importantly, this was theta. This was 180 minus theta. An angle in here would be 180 plus theta, and then obviously an angle in here would be 360 minus theta. It was important to know if cos was negative, right? Where would that occur? If, let's just say, cosine was negative, where would that occur? That means it must be in the sine and the tan region, because cos is positive here. Does that make sense to everybody?
Yeah.
All right. So if that made sense, then pretty much from that you were required to solve. I'll just do, I guess we'll just do the hardest question you're probably going to get. In both advanced and extension, the hardest question you'll probably see for solving will look something along these lines. Let's say 2 sine 3 theta plus 60 degrees, or obviously pi on 3 equals to negative 2. Why is this the hardest question? There's the negative. There is a movement. There is a triple angle, and that's it. Excuse me. So you've got to really know what's happening with your negatives. You've got to really know what's happening with your adding and subtracting. If you're doing it properly, if you've done it the way I've always shown you, maybe from last year or whatever, or even David, these should be really, really straightforward stuff. So let's see, or let's revise on how we do these. First step, your domain, we'll make the domain from, I don't know, we'll make the domain from, I guess we'll keep it standard. We'll keep the domain 0 to, actually no, if I'm going to show you guys everything, we might as well go from negative 2 pi to 2 pi, which like this question you won't ever see, but if you're able to answer this question, that means you really know everything else. So think of it like that. You probably won't get a question like this, but if you're able to answer this question fully, that means you pretty much get all of solving trig. All right, so let's do this. First thing you want to remember, we can never solve for sine unless it's monic. So we've got to divide by the 2. And really stop me if you don't understand something. Then we can never inverse a negative. Well, that's just the way I do it. We don't inverse a negative. So this, I usually write them in little hats to say that it's not the answer. It's not really what we want yet. It's just telling us where inverse sine of 1 is. So inverse sine of 1 is pi on 2, or 90 degrees. I will change these to degrees in a sec. Right, but that's not our answer. That's just giving us our theta that we need to start out all stations to central. So please remember, we don't inverse the negative. Make a note of that. Or just keep repeating this question over and over again until you memorize. You can't inverse negatives. And we should be at this stage. Any questions? Steph, any questions?
No.
No?
No.
Okay, cool. So then at this stage, that's when you do your all stations to central. And you've got to work out where is sine negative. That's the only time you're going to start using the negative case. So where is sine negative in ASTC? Sine is negative here and here. So that means it's in these two regions. So what you're going to do is do for our angle now, so that's why that's in inverted commas, so we're just looking for our theta. Otherwise, if I don't have my theta, I don't know what I'm going to add it to, right? Or I don't know what I'm going to subtract from 360. So now that I know it's 90 degrees, it's going to look like this. 3 theta plus, like I said, it's probably easier for most of us to use 60 degrees, equals not 90. It's not 90. It's 180 plus 90. And then 360 minus 90, which is still 270. So I'm not going to write it again. I'll pause there. Does that make sense? That is actually what 3 theta plus 60 is. It's not 90. That's why I put that in those little hats to say it's not really that, but at least we get to work out what our 90 degrees is. Any questions? Girls? No? Okay. At this stage, can anyone tell me what they would do? Maybe more Azra and Erin. What would you girls do? You should know.
Would you move the 60 over?
Ah, nope. You're going to get them wrong.
Oh, I don't know.
That's
then.
Okay. That's okay. What would you do then, Azra? Only you left now. Do it for the team. Azra? Oh, your mic doesn't work. I forgot. Sorry. Can you tell us what you would have done? Can you type it? If you know what to do, obviously. If you don't, just I don't know. And that's okay. I'll go through it. Do in the other quadrant. Do in the other quadrant. In the other quadrant. Do in the other quadrant. But we already did this other quadrant, right? We did 360 take away 90, and that also gives us 270. 180 plus 90 also gives us 270, so it doesn't really make a difference. Is that what you meant? Do in the other quadrant? Would you keep adding because it's, that's the one. Boom. So the reason why I said I picked this question, if you guys can execute this, it's got every little trick that you're ever going to see. Now what you want to remember, Erin, yourself as well, is if you've got a case like this, not only that is the 3 revolution a problem, it's the fact that you're adding 60 as well. Okay, wait. Let's first understand something. If I'm at 270 degrees, which is somewhere here, not that it's so important, but let's just say it's exactly there. We agree with that? Steph, you agree 270 degrees starting from here is somewhere there?
Yes.
Now, what if I added 360 degrees to that angle? If I added 360 to that, I get 630 degrees. Would my position change?
No.
No, I'm still actually in the same place. What if I subtracted 360 from 270? So what if I went 270, take away 360, and I got negative 90? Have I changed my location yet?
No.
So do you actually see, and this is what I teach to year 11 students, you want to know this, you can add and subtract as many 360s you like. Do more. Keep going, right? Just do a lot. Do it. If you want to do 10, do 10 if you really want to. I mean, this is the hardest one. That's why it's got the 3 theta there. Let's say, so you're going to do it 3 times, 3 revolutions. That's the trick to it. But do more. Like we'll do 4 revolutions or 5 revolutions. It doesn't matter. Then we're going to try and get it in our domain. But what you guys need to understand is you can add and subtract as many 360s you like. And that's super important for you, Aaron, especially in extension 1. You need to know that. Otherwise, you're going to miss answers. So let's pause there. Steph and Aaron, we get that?
Yeah.
100%.
Yeah.
Do you have any questions about the concept of adding or subtracting 360s?
No.
No, that kind of makes sense. And you got to understand when you're allowed to do it. You're only allowed to do it at this stage before you've touched the left-hand side. If you move the minus 60 and then you think you can add 360s and subtract, it's wrong. It doesn't work like that. So before you touch your left-hand side, you can add and subtract as many 360s as you like. Steph, make sense?
No.
What doesn't make sense?
I don't know why do we have to like do the 360?
Ah, why? Okay. I'm just going to fast forward this for a second. I've got to keep going, but I'll fast forward it and look what's going to happen. 270 take away 60. Would you agree? I get 210. Do you agree to that?
Yeah.
Okay. Then I'm going to divide by 3. Do you agree to that?
Mm-hmm.
Okay, so I get 70 degrees. That would have been, I'm guessing, your answer. Maybe even Aaron, who said minus 60, right, girls? That would have been our answer. 70 degrees, we're done. But what if, hypothetically, let's say I'd had this 630. But what's going to happen there? You're going to subtract 60. 630, take away 60 degrees, should give you 570. What if I divide by 3 now? What's going to happen? Oh, I've got 190 degrees. That's still in my domain. So where are all these other answers? And you're going to miss all the other answers. And the reason why you're missing them is because you forgot about the whole adding and subtracting 360s. Because you're going to divide by 3, you're going to reduce these angles. So that means technically you're going to overestimate. So by the time you divide by 3, it gets it within our domain. Steph, make sense now? Or do you see why you've got to do it now?
I don't know, I'm still a bit confused.
Well, you said why, and I explained the why now. You're confused maybe because of it's the fact that it's year 11 and you haven't done it in a while. But
I've just never done it with 360.
no, you've never. The only people that would do it this way are my students. Otherwise, teachers don't teach this. They teach about going anti-clockwise, blah 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 blah, which just doesn't work for the harder questions. Which is maybe why Aaron's now saying also, hey, can we go over the extension 1 trig, because it's not very well taught. So you can add and subtract as many 360s as you like. That's technically my specific way of doing these, because I know they don't fail you. Well, now you've got to learn it. And the only time you're going to do it, Steph, is if there are 3 theta or 2 theta. If it was just a single theta, I guess you wouldn't need to do it so much, because you're not going to be dividing by 3.
If I did it with 70 degrees, like if I ended up getting there and then I keep having answers that fit in the domain, would it still be right?
Say that again.
Like if I ended up with 70 at the end.
Yes.
And I needed to make it fit into the domain that we have.
Right. Let's just say if it was 0 to 2 pi, right? And then what would you have done? But you would have missed the 190.
Well, would I've
No. You're trying to say, well, can I get away with it? But I'll be honest with you, you can't. I wish I could say, hey, do it like a different way. You actually can't. If you want a method that will work regardless of the question, it's this method here. If you want a method that works for the easier ones, and then you've got to change it for the, I guess, the medium ones, and then you've got to change it again for the harder ones, then that's your teachers. You want a method that's flawless regardless, advanced, extension 1, extension 2, it's this exact method. Okay, done. That means regardless, we've got to just do it always like this. All right, let's continue then. Let's go back. So we're allowed to add and subtract 360s. So we add more, and I'm just going to keep adding. I'll just keep adding. I'll add a few times. So that's I'm going to first add. So there it is. I'll add one more. I'll add one more. Why not? Okay. I'm over adding, right? I hope you guys can see that, but it's allowed. All of these angles are allowed. It's just that they're outside of my domain when I'm going to bring it down eventually. But they're actually all technically correct because they're all going to be back down here. The problem is I'd said negative 2 pi. So that means you're also going to subtract 360. So now I'm going to show you the ones that if they were subtracted. So 270 take away 360 is negative 90. Subtract 360 again. Negative 450. Subtract 360 again. Negative 810. Subtract 360 again. Okay, I'll stop there. Anyone have any questions at this stage? And doesn't the logic of it make sense? Here, Erin, I know you haven't done it this way because you would have started this year, but does it make sense to you what I'm doing so far right now?
Yeah, makes sense.
All I'm allowing myself to do is add 360, so I'm not changing the position, but I am increasing the angle. So when I have to eventually subtract 60 and divide by 3, I can find all of the angles that are within this domain.
Yeah.
That's it. All right, so let's see. Let's finish this bit off. 3 theta. I'm going to subtract 60 now. So 270 take away 60 is 210. 630 take away 70 is 560. 990 take away 60 is 930. All right, I'll just keep doing this. Negative 90 take away 60 is negative 150. Negative 450. Negative 450 take away 60 should be negative 510. Negative 870. Negative 12. Oh, negative 1170 take away 60. Negative 1230, right? Negative 1230. Last one. Negative 1530 take away 60. Negative 1590. This is the proper way of what should have been taught. You know, I know, Steph, you're like, oh, I never got taught this way. Let's say that's cool, but realistically, this is the proper way, because then that means you really start to understand how to do it. Again, you understand how to do it for the harder questions, but you'll understand what to do when there's been movements, which is exactly what's happening here with the revolutions and everything. So 70 degrees, 560 divided by 3 is, I'm just going to write them in terms of degrees for now. 187 degrees. This has been rounded. 930 divided by 3 is 310. 1290 divided by 3, 430. So that's too large, right? Too large. So now I know this one's going to be obviously too large as well. Negative 150 divided by 3 is negative 50. Negative 510 divided by 3. You can see why I said do more as well. So it's fine doing more. It's not wrong. It's just that when it's, at least you get the other angles out that everybody else misses. And negative 870 divided by 3. Negative 290, which is still in our domain. Negative 1230 divided by 3. Negative 410, which is too large. So these two are too large. So the answers for if it was 0 to 360, that's what the answers were. And obviously for the domain that I've written, it's all of this. So the concept's not that hard. It's just that you guys are not used to adding and subtracting as many as you like. And as you do more and more, you'll learn if it's 3 theta, you'll do it 3 times. If it's 2 theta, you'll do it 2 times. If it's theta, you've never done it. And then obviously if it's plus, you should always think of the opposite of it. So you're going to minus it, which means maybe you should have added 360. So by the time you subtract it, it's going to get you maybe inside your domain. All right. What do we reckon?
I have a question.
Yes.
Well, when you sign inverse it, like what did you do with the negative?
Yeah, that's a very good point. We don't inverse sign negatives
Yeah.
as well. We don't inverse cos negatives. We don't inverse tan negative.
Yeah.
Yeah, so actually that negative tells you what only? That sign is negative. So when you're drawing your all stations to central,
Yeah.
where is sign negative in tan and cos?
Oh, okay. So you just like
that-
neglect it pretty much.
Yeah, you have to neglect it. That negative
Yeah.
is just there to tell you that it's. But then, see, again, your teacher's method, they probably didn't neglect it. And
Yeah.
that's what would have got you guys confused. And then, again, it works sometimes, doesn't work other times. And it's not the way I do it.
Okay. Yeah.
So from now on, if you want to write that, right when we're solving, if there's negatives, when we're inversing, we ignore the negative. That just tells us the angle we're looking for. Then we ask ourselves, where is that trig negative? Okay, it's here and here, whatever it is. Then that's what you're trying to use. 180 plus theta, 180 plus 90. That's why I have it in these little hats as well, because it's not really the answer. This isn't really 90. It's actually 270. But that 90 we need, so we can actually go 180 plus 90. Okay. So I did say before I start, I say if you can do this one, right? If you guys can just literally repeat this again and again and again and master every single step, pretty much you can tell yourself, I've done the hardest one, I'm good. It's done. Every trick is there. There's nothing else I can show you that will stump you. So now I'm going to tone it down. And we'll do one more. And see if it makes sense this time around. Okay. Let's try cos theta equals -1 on root 2. Cos theta equals -1 on root 2. All right. And then we'll just try to do it from 0 to theta to 2 pi. Of course, if it was pi, you're going to divide everything by 180 in pi. I think I don't need to talk about that, but we'll do it properly for this next one. Cos theta is -1 on root 2. Try it out real quick. There is no, I guess, real adding or subtracting. This is just the basic one. Just to recap it. All right, so first thing I would do is inverse. So it's not really theta, it's actually theta with a little hat. Inverse cos 1 on root 2. What's inverse cos 1 on root 2? Should give you 45. Yeah. Then the whole point of that negative is to tell you that cos is negative. Cos theta equals -1 on root 2. So where's cos negative? Here and here, S and T. What are my angles there? 180 minus 180 plus. So what's your actual theta? 180 minus 45, 180 plus 45. And that's it. And then divide by pi, whatever. Steph, makes sense?
Yeah.
Yeah?
Mm.
And then see, the problem is, what if this wasn't theta? Wait, Erin, all good as well?
Yeah.
So what if it wasn't theta? Right? What if it was 2, 2, 2 theta? The problem is when you're going to divide by 2, it's all fine, like you'll get an answer. The thing is, if you had more answers, if you were going to divide by 2 as well, you might have gotten them in our domain. So if you don't know the whole trick of the adding and subtracting 360s, you won't get those answers out. So we're going to quickly make it into a 2 theta. I just wanted to show you everything stays the same, except just this line here. Once you've got your 2 answers, you add 360. If you want to add more, you can do it. If you want to add it, to 495, add 360 to that as well, you can. But I know I won't. You don't need to, so I'm not going to. And that's 585. And then your answers are 135 onto, 225 onto, 495 onto, and 585 on 2. All good?
Yeah.
And then check the answer to 585 on 2. It's what? 292 degrees 50. So that's still within 0 to 360. So thank God I did that. All right. Steph, all good?
Yep.
So that's pretty much year 11 trig. That was like the biggest thing you wanted to learn in year 11. That part of solving, and then I guess those formulas. Then we got to year 12. Year 12 trig. For advanced, there was just differentiating. Sorry?
Integrating tree.
Yeah, differentiating, integrating, limit x approaches 0 of sine x on x, and I think that's about it. You would have learned curve sketching as well. Curve sketching.
Do we do area with tree?
Yeah, that's part of integration.
Oh, okay, yeah.
I can't think of anything else, but let's have a look now. The behavior. Yep. Blah, 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 blah. I know it. Differentiating, integrating. Yeah, that's even better. Differentiating, finding gradients, tangents. Everything comes into play. So in year 12, in year 12, it was just about applying trig as a function. So you could do differentiating, you could do stationary points, you can do points of inflections with trig, you can do, like you said, area, you can do volume in extension 1. What else? You can find tangents, normals. So everything else is standard. It's just a function. Well, first you need to know how to differentiate it to find, equation of a tangent. They're not too hard actually differentiating. The trick with it, again, a bit of revision. Going down was to differentiate. Going up was to integrate. So sines become causes. Causes become negative signs. Negative signs become negative cos, and so on, and vice versa. If you're integrating, cos becomes sine, sine becomes negative cos, negative sine becomes cos. Okay, I think we get that. More importantly, for differentiating trig, was you got to kind of follow what we say is like almost the chain rule, right? Now the chain rule says to differentiate the inside as well. And that's technically what you've got to do, so you can't forget that. So y dash, so sine becomes cos, so there it is, cos of x squared, but you've got to still differentiate the inside. So the derivative of x squared is 2x. So the answer is 2x cos x squared. Do we get that, girls?
Yeah.
Steph, all good as well?
Yep.
Okay, so that was pretty much, I guess that's the hardest one. I mean, again, you can use quotient rule. I can make it a bit harder and put exponentials in there, but It's not that it's harder, really. The concept stays the same. You just got to do u dash v minus v dash u and whatever. Shouldn't be too complicated. You just follow your rules. Nothing too crazy there. Integration, same thing. You can't integrate nonlinear angles, so you won't get integrations for like this. It'll only be like sine x or a variation of sine x. So let's just do the hardest one I can think of for this. Let's do the integral of negative 2 sine x on 4. Okay, so the integral of negative sine is positive cos. So that becomes 2, because that can't change, right? Just like anything else, you multiply. If it's multiplied, you don't change it. 2 cos. Your angle doesn't change. Your angle cannot change. Just like your exponentials, the powers never changed. But you've got to divide by the derivative of the inside. See how here we multiplied by the derivative of the inside? You've got to divide by the derivative of the inside. So what you've just learned from these two basic cases is that technically you're always differentiating. Even if you're integrating, you're still differentiating. It's just that if you're integrating, you're going to divide by the derivative. Whereas if you're differentiating, you're going to multiply by the derivative. And then the answer just becomes 8 cos x on 4 plus c. All right, what do you reckon? Any questions there?
No.
Okay. Do we need more, or is that okay to get started for now? All right. So then we did that limit question. Easiest 2 marks you're going to get. Limit x approaches 0 of sine x on x equals to 1. The idea with these questions were it's going to ask you to find the limit as x approaches 0 for sine 3x on, let's say, 2x. And the logic was to always make sure that these x's were the same. So what we want, limit x approaches 0, we want to make sure they are exactly the same. So that because once they are exactly the same, I can use this result. But you can't just make a 2x into a 3x. It's not allowed. So the trick to it was, when you did do that, you did make them the same, you multiply it by 3 over 2. You see that? 3 over 2. This answer here is 1 times 3 over 2. What's the answer? 3 over 2. Now everyone goes, oh, but then don't you just know the answer? You can't write it because we want to see that result. Any questions? Do we need one more of this?
Yes, please.
So the limit, and I think for sine and tan they're the same actually. So limit x approaches 0, tan x on x equals to 1. So then, what do I have? So then I've got, if I've got a question that goes, find the limit x approaches 0 of tan x on 5x. Like I said, make sure that the angles are the same. You're never going to make that into a 5x. You can't change the angle inside your trig, right? That's just impossible. So what you're going to do is make this the same. Can anyone tell me what you're going to multiply it by?
Would be 1 on 5.
It will be 1 on 5. That's the trick, and then that just becomes 1. And what we want to just see is 1 times 1 on 5, and that's it. Now you'll get 2 marks. So you can technically see the answer. But like I said, we need to see the working out of it. Unfortunately, that's just how it's going to be. So easiest 2 marks. Just, you probably get. Just be careful with it. Steph, what do you reckon? All good? Yep. Steph, I can't hear you. Okay, let's see. Is that advanced or extension? Looks more like extension up there. Yeah, it's definitely extension. Okay. Oh, those ones are great. I need to show you guys just one of these so you guys understand how to use these properly. Oh yeah, derivative of tan is sec squared x as well. Forgot to that. I'll write that instead. Just trying to find you one. Oh no, that is that one. It is that one. Okay, that's perfect. That one's good because that becomes that. Yep, both of these are good. All right. Okay, so differentiate this. D on dx sine to the power of 5x. All right. Oh. And then don't forget, you got to differentiate the inside. So the derivative of sine is cos. And that's what we end up with. So 5 sine to the power of 4x cos x. Any questions? Nope. All good. Okay. Then it says hence integrate sine to the power of 4x cos x dx. Okay. Erin, if I had integrated this, what would the answer be? So what would the answer be for the integral of 5 sine to the power of 4x cos x?
Would it
Yeah.
be sine x to the power of 5?
Right? So it'll just go back up because the derivative of this is this, which means the integral of this must go back up to the top.
Yeah.
That makes sense. But this time I've got the exact same expression without the 5. So if I don't have a 5 here, obviously the answer is sine x to the power of 5. And then what do you think? What do you think happened to the 5?
Do you times it by like 1 on 5?
Yeah, so you can divide by 5. That's it.
Yeah.
So instead of being multiplied by 5, that 5 would have been obviously divided to here. So it looks something like this if I had to show you guys it like this. Do we agree with that? The integral of 5 sine 4x cos x dx is equal to this. Or what are you allowed to do with the 5? Divide by the 5. Of course. So. b. Let's try that again. Y equals tan cubed x. Okay, the derivative of tan x is sec squared x. So if I'm trying to differentiate tan cubed, you bring the 3 down. You still got tan squared. But then you got to differentiate the tan x in the inside, which becomes sec squared x. Any questions there? Steph, any questions?
No.
That makes sense so far?
Mhm.
Then, again, we're trying to integrate just tan squared sec squared. So we're saying hence, integrate just tan squared sec squared. Well, again, if you want to write it the way I had written it, you know that 3 tan squared sec squared integrated would become tan cubed. That's what you just worked out. So you don't have a 3, so you're going to obviously divide by that 3. So the answer is tan cubed x on 3 plus c. Any questions? No? Alright, that's that bit done. I guess we'll just do an area style question as well, just to see that, and then we'll move on to extension 1. So let's have a look. I'd rather find an exam question. So let's do that. I'm going to close this up now, and we'll actually try to find a hard HSE exam. This is HSE exams. Advanced math. Where are they? Let's see if there was one here. Max min problem, and then loan repayment. See, as I said last week, loan repayment, last one, max min, there it is. But anyways, that's not what we're looking at right now. And 17. What just happened? Nothing yet. Max min, and that was geometry, and that's a limiting sum. Where's the loan repayment? Right there. That's still not what we want. What we want. Maybe I'll close these guys. There's not many in the HSC. There's usually a lot more in trial exams. So let's just try these guys. Okay. We've got that one, that one. Trapezoidal rule for log. We don't need to do that now. Logs. Oh. No, it's an easy one. Still didn't do trig. show, hence solve. Question 16. Okay, we'll do that. That's okay. Let's do these few. I tried to find an area one. It looks like I'm failing, so let's just do these. It's okay. All right. Start with differentiating. And I guess if just from this, you can already tell how many marks it's going to be. Trig itself overall looks about 10, 12 marks. Start with triple I, please. I'll stop the recording and give you guys